This is Grade 12 University Physics, Unit 1 Dynamics, Lesson 6 Acceleration due to Gravity. And this is the flower pot question from your homework today. Here we have a flower pot is dropped from the balcony of an apartment 28.5 meters above the ground. At a time of 1.0 seconds after the pot is dropped, a ball is thrown vertically downward from the balcony 1 story below, 26 meters above the ground. The initial velocity of the ball is 12 meters per second down. Does the ball pass the flower pot before striking the ground? And if so, how far above the ground are the two objects when the ball passes the flower pot? So there's a lot of words to this question. So we draw everything, draw what we see, and write what we know on our picture. So we know the flower pot has an initial velocity of 0, and it is 28.5 meters above the ground. At a time 1 second later, the ball has an initial velocity of 12 meters per second down and is 26 meters above the ground. Okay, now let's assume they're going to meet at this point here. Now this is an arbitrary point. This point could be above the ground, or it could be below the ground, and therefore they wouldn't meet at all. But if they're to meet here, we can say that the displacement at this point of the flower pot is equal to the displacement of the ball, plus the flower pot traveled an extra 2.5 meters because it was 1 floor higher, and that is the difference of 28.5 and 26 meters. Now we also have another piece of information. The question said the ball is dropped 1 second after the flower pot is. So the amount of time to reach that point where they meet for the flower pot would equal the time of the ball plus 1 more second, because the flower pot took 1 more second to get there since it had a head start. These two equations are important to figure out in order to solve this question. We need to somehow relate the ball and the flower pot to each other. So let's start with our displacement equation, and we're going to expand on this one. And for each displacement, we're going to write out an equation from uniform acceleration. Now this equation, we're going to continue to expand, but you'll notice in this equation we have two unknowns, the time for the flower pot and the time for the ball. So we can't solve for anything. This is where our other equation comes into it. We can take our time equation, which relates the time of the flower pot and the time of the ball, and substitute it in. Once we do that, we have one equation with one unknown, the time for the ball. It's a little bit messy, but first we expand. Some terms will cancel. Then we can rearrange, collect like terms, and we solve for the time it takes for the ball, once it's thrown down, to actually meet the flower pot to be 1.09 seconds. Now the time for the flower pot to reach that point would be exactly 1 second more, so 2.09 seconds. Now let's figure out how far the flower pot actually has traveled in 2.09 seconds. Was it greater than 28.5 meters and therefore hit the ground before the ball caught up to it, or was it less than that? When we look at our equation, we get 21.4 meters, so it only fell 21.4 meters before the ball caught up to it. So, and that's to the first part of the question, the ball does catch up to the flower pot. Looking at the second part, how far above the ground are the two objects when the ball passes the flower pot? Since we know the flower pot was initially 28.5 meters above the ground and it fell 21.4 meters before the ball met it, we subtracted 2 and we found out that the ball caught up to the flower pot 7.1 meters above the ground.